I'm going to go over the answers and the problems that I did not address in the notes from section 1 on the basic counting principle. Before I do, I just wanted to um, acknowledge that we are going through an interesting time. I understand that. Just know that I'm going to try to provide the best education that I can under the circumstances that we're in. If you get any questions at all, please feel free to email me. You can send me a picture in the email. You could maybe write out what you're thinking, however you want to show me your work, and I'd be happy to get back to you as you're working through some of these problems. Some are going to be challenging and difficult, and I just want you to do your best. Please make sure you're showing your work, um, meaning showing me what numbers you're multiplying or adding, or what calculations you're making in order to get your answers. All right, so I went through 1 through 4 in the notes. So we're going to pick up at number 5, and it relates to number 4. It says, consider exercise 4 above if repeats are not allowed. And what we have is a 6-character license plate where the first 3 characters are going to be letters, and there's 26 letters in the alphabet. And then the last 3 characters will be digits. Digits are the numbers 0 through 9, and there's 10 digits. So if my first choice is going to be a letter from the alphabet, there's 26 options that I have, but I've already picked one for my first, so when I pick my second letter, I can't pick whatever I picked first, so now I only have 25 options. When I pick my third letter, I've already picked 2 of the 26, so now there's only 24 options left. Then I want to pick a digit. There are 10 digits, 0 through 9 available. I pick 1, I can't repeat, so now there's 9 digits available, and then 8 digits available. And you just multiply these numbers together using a calculator, and you get 11,232,000 as an answer. Alright, skipping now to number 7. On a certain website, passwords are 3 characters long. The characters can be any letter or digit or these symbols, the plus, times, and so on. How many possible passwords are there? Okay, so again, we have 3 characters, and we just want to ask ourselves, how many options do we have for each character? Well, there are 26 letters, plus we got 10 digits, plus how many additional symbols? 1, 2, 3, 4. And so we have 40 total options. Here it doesn't state if we can repeat or not. At least I didn't see that. I'm going to reread that just to make sure. And so let's assume if it doesn't say we can't repeat, then by default we're going to be able to repeat. So we have 40 options for the first selection, 40 for the second, 40 for the third, and you multiply that together, you get 64,000. Now in your homework, if you did this problem assuming you couldn't repeat, and you did like 40 times 39 times 38, that would be acceptable to me too, because it doesn't really clarify which one it is. But that's our answer. Again, look at how I'm showing my work. I'm not just putting 64,000, I'm showing what was multiplied together to get that. And that's going to be important. Number 8 was an extra credit problem, meaning give it your best shot, but it's going to be a little more challenging here. Also, the answer is not in the answer key because it's extra credit. Here we have a library that issues cards with 4-digit numbers, None of them begin or end with 0. Furthermore, none of the numbers have the middle 2 digits both 0. How many different digits can there be? And so the way I handled this is I split it into 3 cases. The first case, let's assume that we have no zeros at all. Okay, because that can happen. And these are 4-digit numbers, and we're just going to look at what we can get with no zeros. It doesn't say we can't repeat, so we're going to assume we can repeat. And so we have 9 options for our first digit, because there's 10 options, 1 through 9. We can't use a 0. 9 for our second, third, and fourth. So 9 times 9 times 9 times 9, which is 6,561 ways to get a 4-digit number that doesn't have any zeros. Now let's consider the case where you have a 0 in the second spot. Because if you read through this, you'll see that you can't start or end with a 0, and the middle 2 can't be 0. So that means you can either have no zeros or just 1 0. And if you have 1 0, it's got to be in the second spot or in the third spot. So if it's in the second spot, then I have 9 options for my first spot. It could be a 1 through 9 times my second spot. I know it's going to be a 0, so there's only 1 option. And then my third spot, anything but a 0. My fourth spot, anything but a 0. So 9 times 1 times 9 times 9, which gives me 729. And then the other option is you can have a 0 in the third spot. And so it's like the second spot. You'd have 9 options for first, 9 options for the second, only 1 option for the third spot because it's going to be a 0, and then 9 options for the fourth spot. And again, you get another 729. So it could be the first case, second case, or third case. And so to get the final answer is you add those up. So 6561 plus 729 plus 729, and you get a final answer of 8,019. Number 9. Shelley remembers that her pin consisted of 4 distinct odd digits. How many such pins are there? So you have 4 digits. They're odd. The odd numbers you got 1. The odd digits would be 1, 3, 5, 7, and 9. So you have 5 odd digits to choose from. They're distinct, which means you're not going to repeat. Okay, that's what the word distinct is going to mean. And so here we have 5 options for our first pick, and then 4, and then 3, and then 2, and you multiply that together and you get 120 different pins available. And number 10 is a multiple choice problem. So again, you won't find your answer in the answer key at the bottom because you have one of these A, B, C, D, or E will be your answer. And it says, how many passwords are there that fit the following condition? A password is to be 6 letters long. So 1, 2, 3, 4, 5, 6. Alternating consonants and vowels. Starting with a consonant. No repetitions are allowed among the vowels. Okay, but it doesn't say no repetitions are allowed along with the consonants. So you can repeat consonants, but you can't repeat vowels. There are 26 letters in the alphabet, and we can split those up between vowels and consonants. I can't spell consonants, sorry about that. Let me fix that. And your vowels are A, E, I, O, U, and Y, so there's 6 vowels, which means the remaining 20 are consonants, right? So I'm going to start with a consonant, which is, I got 20 options. And then I get to a vowel, which there are 6 options for a vowel. And then a consonant, which I can repeat, so I got 20 options. And then a vowel, which I can't repeat, so I already used 1, so now I have 5 options. And then a consonant can repeat, and then a vowel you can't repeat. So your vowels are dropping from 6 to 5 to 4, where the consonants are remaining the same. Okay, you multiply those together, and you get your answer of 960,000. So our answer here will be C. All right, I hope that helped, and I will be posting more videos. And again, feel free to email me with any concerns or questions or anything you want. All right.